Good morning, friends. Today I am going to discuss about solar cell. A solar cell is a device that converts light energy into electrical energy using the photovoltaic effect. A solar cell is also known as photovoltaic cell. A solar cell is made up of two types of semiconductors. One is called a p-type silicon layer and second one is called n-type silicon layer. So solar cell is a p-n junction diode. The solar energy from the sun in the form of photons, which creates to loose electrons on the N-type semiconductor and holes on the P-type semiconductor. These may loss electrons are collected on the aluminum layer and start following the result in an electric current. Solar cell. A solar cell is a device that converts light energy into electrical energy using photovoltaic effect. It is also known as photovoltaic cell. A solar cell is made up of two types of silicon layers. One is N-type silicon semiconductor and another one is a P-type silicon semiconductor type. There is a reflective coat covered above the solar cell to prevent any external shocks. And the solar cell's middle layer is known as p-n junction diode. When the sunlight falls on the solar cell, the solar energy from the sun in the form of photons create loss electrons on the N-type semiconductor holes on the P-type semiconductor. These created to loss electrons. These created loose electrons on the aluminum. These created loose electrons are collected on the aluminum layer and start flowing, thus resulting in generating the electric current. Key terminologies in solar cell. Terminologies in solar cell. A solar cell is one of the primary main key technology. It is a device that converts light energy into solar cell is a device which converts light energy in the form of sunlight into electrical energy using photovoltaic effect. Photovoltaic effect is a phenomenon when some materials are exposed to light, then it generates electric current. Solar panel is a collection of solar cells which are connected to produce a higher level electrical output. Solar array is a system where it contains multiple solar panels which is designed to generate a large amount of electricity. Properties of solar cell. Solar cell higher efficiency and convert in using photovoltaic effect. Solar cell has more durability and resistance to environmental conditions. Solar cell provide a long-term performance and has a higher lifespan, and solar cell has no maintenance cost. Construction of solar cell. A solar cell is basically made up of p-n junction diode. Solar cell principal layer is made up of anti-reflective cover glass because it protects the semiconductor materials against the sunlight. Solar cell consists of small grid patterns with slight metallic strips are available under the glass. The top layer of solar cell is made using glass, metallic strips and anti-reflective coat. Solar cell consists of two semiconductor layers which are made up of p-type and n-type materials. A very thin layer of p-type semiconductor is grown on the relatively thicker n-type semiconductor. We need to apply a few finer electrodes on the top of the p-type semiconductor layer so that these electrodes do not obstruct the light to reach the thin p-type layer. Just below the p-type layer there is a p-n junction. We need to provide a current collecting electrode at the bottom of the n-type layer. The base layer of the cell consists of two parts. A rear metallic electrode is beneath the p-type semiconductor and it works with the metallic grid to generate an electric current. A reflective layer is the last layer in this cell used to decrease the loss of light within the system. Solar cell top layer is covered with anti-reflective cover glass to prevent from any mechanical shocks. Working of solar cell. Working of a solar cell. When the light energy falls on the solar panel, the solar panel absorbs the light energy. Each solar cell in solar panel has a semiconductor which has the properties like insulator and metal, which when the energy of sun falls on the panel, then a semiconductor material on the panel absorbs the energy of photons, transfers to electrons and allows the flow of electrons through the material like an electric current. When the sunlight reaches p-n junction between p-type and n-type semiconductors, photon easily enters through the thin p-type layer. The photons provide energy to the p-n junction, creating electron-hole pairs. This light disrupts the thermal equilibrium condition of the junction. Then the free electrons to move to the n-type side of the junction. The hole moves to the junction's p-type side is a similar pattern. As a result, free electrons on the n-type falls to move past the junction due to the potential barrier. The same barrier potential of the junction blocks the newly created holes, which causes an increased concentration of electrons on one side at the p-n-type junction and holes at the other side. This is the process involved in working of the solar cell. Let us see the different types of solar cell: monocrystalline solar cell, polycrystalline solar cell, thin film solar cell. In monocrystalline solar cell, it cut from a single it's a pure crystal of silicon. It have been made up of silicon wafers. These wafers are assembled into rows and columns to form a rectangle covered with a glass sheet and framed together. Monocrystalline solar cells are easily recognizable because of their black color. It appears black because how light interacts with the pure silicon crystal. It have a variety of colors. It have further black sheets and frames. Polycrystalline solar cell. Like the monocrystalline solar cell and the polycrystalline solar cell do not require each of the four sides to be cut. Instead, the silicon is melted and poured it into the square mold. Then this forms perfect shaped square cells. Monocrystalline solar cells and polycrystalline solar cells vary in the composition of silicon itself. Polycrystalline solar cells are composed of fragments of silicon crystals that are melted together in a mold before cut into wafers. Polycrystalline solar cells have a bluish hue due to the light reflecting off the silicon fragments in the cell in a different way. Similar to monocrystalline solar cells, polycrystalline solar cells have a variety of colors for their backsheets and frames. Thin film solar cell, and these are made from a variety of materials. As the name indicates, it is slimmer than other solar cell types. It's the most prevalent type, and the cell is made up of cadmium telluride. Manufacturer places a layer of cadmium telluride between transparent conducting layers that help capture sunlight. Copper, indium, gallium selenide panels are the popular type of thin film technology. Copper, indium, gallium selenide are the popular type of thin film technology. Comparison table of different type of cells. When we compare efficiency in monocrystalline solar cell, it avails 14 to 18 percentage of solar cell efficiency. In polycrystalline solar cell, it is 12 to 14 percentage. Uh, in thin film, efficiency will be 5 to 6 percentage. In more, when we when we compare temperature tolerance, 0 to 5 percentage in monocrystalline solar cells, -5 to +5 in polycrystalline solar cells, and -3 to +3 percentage in thin film solar cells. When we compare the lifetime in monocrystalline solar cells, it will be 25 to 30 years. In polycrystalline solar cell, 20 to 25 years. In thin film, 15 to 20 years durability. In monocrystalline solar cells, hail resistant, 25-year PNDM. For monocrystalline, polycrystalline, thin film, all durability will be hail resistant, 25 year part per million. 25 year PNDM warranty. Application of solar cell. We use solar cell as a power supply to home to reduce the electricity bill. We use the solar panels for industrial and commercial business to provide power from solar arrays. We use solar panels for street lighting and public space streets. We use solar panels for agricultural solar pumps, which is useful for irrigation and powering equipments in farm. We use solar panels for off-grid power supply systems, mainly in remote areas without access to the electricity. Advantages and disadvantages of solar cell. In monocrystalline, first we see the advantages. In monocrystalline solar cell, it has high efficiency. It is used in aesthetics. It performs better in low level of sunlight. It requires less space. In polycrystalline, cost will be low. It avoids silicon waste and it is easy to use. In thin film solar cells, portable, flexible, lightweight, aesthetics. Disadvantages: higher cost, lot of waste material when silicon is cut during manufacturing. In monocrystalline solar cells, in polycrystalline cell, it has a disadvantages of lower efficiency and requires more space. In thin film solar cells, the disadvantages: lowest efficiency, shorter lifespan. While summarizing the passage, solar cell is a device which converts light energy into electrical energy using photovoltaic effect. And the terminologies and properties of the solar cell have seen and gone through the working and construction of solar cell. And the three different types of solar cell have been seen. Also, the application of solar cells will be learned. And also, we see the advantages and disadvantages of solar cell. and also applications of solar cell will be learned. Finally, the solar cell plays an important role in maintaining the sustainable environment and eco-friendly environment. Solar cells are becoming more popular and efficient and is used in residential home or commercial residence and industrial applications in our daily life.